All right, well, welcome back. I hope everybody's having a good first day. We are going to continue where we left off that last week, kind of morphed into, review and then get ready for the final. We had the district assessment. So it's been a while. I want to go ahead and take the first day back to review ourselves on the inverses. So this paper was actually the homework assignment. We're just going to go through, choose some problems today, work them together. We'll go ahead and turn it in at the very end just as a participation grade. Go ahead and start the whole process. But hopefully today we'll kind of remind you about what we were doing before the break, because I'm sure everybody was just looking at pre-calculus the entire break, right? Exactly. There you go. Exactly. Well, a couple things. On the website as well as on the board. We have our first quiz on Thursday, so in a couple of days, and it's going to cover this material. It's going to be over the inverses of trig functions, but we're only so far looking at sine, cosine, and tangent. The next couple of days, we are going to look at cosecant inverse, secant inverse, and cotangent inverse, but I want to go ahead, like I said, review and make sure that we're all back on the same page before we go ahead and move on. But that's what the quiz on Thursday is going to cover. This is still a ways out, but I thought I'd go ahead and put it up there just so you can mark it on your calendars or just kind of know it's coming. 2 weeks from Thursday on January the 24th, so the third week back, that's when we're going to have our first exam. And exams, quizzes, remember what can be done during those. You can use your notes. You can use your notes. Okay, so anything you write down is definitely going to be fair game. Since you're in new seats now, make sure you're grabbing the calculator that's your desk number, not your old one. If you grabbed your old one today, that's fine. We'll just put it back, as you leave. But you also have new villain buddies. If you look around you, the villains have the same colors, whether it's green, purple, orange, whatever the case is. Those are your new villain buddies. So hopefully you're with somebody you don't know and hopefully make a new friend. We'll kind of see how that works out. But I think that's all I got, unless anybody has any questions. Okay. Did everybody also grab a protractor when they walked in? Okay. If you didn't grab a protractor, I'll go ahead and give you a second to go ahead and do so. We'll review and then just see how far we get. Okay. All right. If you'll recall, before the break, we were using a protractor to help me with inverses that weren't giving me special right triangles. We'll review those in just a second as well. Oh, you did your calculator? Okay. Everybody have a good break? Anybody go anywhere? I went to Slayton, so I went far. Anybody go out of Texas or out of the U.S.? I had one student go to London.
I went to my grandma's house.
Where's your grandma's house?
Down the street.
Oh, there you go. Hey, you got to go somewhere. Like I said, I got to go to Slayton, not far, but hey. Anybody? Where'd you go? Oh, South Padre? Okay, nice. You went to the kitchen?
Yeah.
It's always a great destination. Okay. All right. Well, we're talking about inverses. So let's go ahead. We got 6 trig functions, and this applies, to all of them. But somebody give me one of the 6 trig functions we've been talking about. Sine. Okay, let's say with sine. Now remember, this applies to all of them, right? But sine. Now, what do I normally plug into the original trig function? Oh, now that's the ratio. But what do I always plug in? What is it? Is it a ratio of sides or an angle measure? Okay, whatever you plug into the normal trig function is always an angle, right? Okay, whether it's in degrees or radians, that makes no difference. Now, when you evaluate a trig function at an angle measure, like we do here, that's when you get a ratio. Like, remember sine, a lot of people were telling me it's the opposite over the hypotenuse, y over r. If it's cosine, it's the adjacent over the hypotenuse. So it always gives you a ratio of the sides of a right triangle. Now, what we're going to go ahead and do is work backwards, given the ratio, to find the angle. And if we want to do that, well, that's when we take the inverse. So the only thing we plug into an inverse function is a ratio. And the answer we're going to get is the angle measure. And whatever mode your calculator is set in, hopefully it's still in degrees, that is the answer that it's going to go ahead and provide you. If it's in radians, it'll go ahead and give you that in radians. And like I said, the same applies for cosine, tangent, all the way through cotangent. Does not matter. Okay. Well, a few other things. We were talking about how to solve these using special right triangles. So there are a few that are special. Let me go ahead and get a couple of triangles here. And these are both going to look the same, and that's perfectly fine. Okay. So one of the special right triangles is a 45, 45, 90. Now I want to rewrite everything in terms of x. It's the pattern that you're looking for here. This is the only isosceles right triangle that we have. So what does that mean about these two legs of the 45, 45, 90? They're the same. So both of these are just x units long, whatever unit of measurement you have, inches, centimeters, whatever. Okay. But given one of those sides, x, whatever that is, how would I find the hypotenuse? You could absolutely use the Pythagorean theorem. Okay, there you go. All right. So I want to take x and multiply it by the square root of 2. Or as Brandon said, you could use the Pythagorean theorem. But the shortcut, if you know you're dealing with a 45, 45, 90, take the length of the leg and simply multiply it by the square root of 2. Okay. What's the other special right triangle we've been talking about? 30, 60, 90. Okay, so let's say this is 30, this is 60 degrees, there's a 90. Now, one of these three sides is x. Is it across from the 30, 60, or 90? Okay, across from the 30 is always the smallest. So that's my x. Now, how would I find, oh, okay, 2x is what? There you go, across from the 90, that's the hypotenuse. If I want to know the length of the hypotenuse, I take the shorter side and double it. The hypotenuse in this triangle is always 2x. Now, what do I multiply x by for the longer leg? X square root of 3. There we go. So the idea being that if I have one of the three sides, I can find the other two pretty easily. But what we're doing here, we just want to identify what type of triangle it is. Okay. We want to identify what type of triangle it is so that we can go ahead and get, my answer, because we're looking for that angle measure. All right, and I'll come bring all this back together in just a moment. So let's, one more thing, review our inverse trig functions that we've been talking about. So we had sine inverse of x is equal to theta. Cosine inverse of x is equal to theta. And tangent inverse of x, which is equal to theta. Now remember, we know we plug a ratio, the sides of a triangle, into an inverse, and you get an angle measure. Again, whether radians or degrees does not matter. But it's really important we know what the restrictions are. Okay? For example, the only ratio that I could input for sine inverse has to be between -1 and 1. If I try to plug in anything outside of that interval, it's not going to work. Okay, what other trig function has the same input? Is it cosine inverse or tangent inverse? It's cosine inverse. There we go. I got to put in the same thing. So that's -1 to 1. Now their outputs, the answers are going to be restricted to certain quadrants. Does anybody remember what quadrant sine inverse was going to be in? It was 1 and 4. It was the right side of the unit circle. So my answers have to be between -pi/2 and pi/2. Okay. If I'm looking at the unit circle, we are restricted to the right side. Okay. Now for cosine inverse, one of the quadrants was the same, but not both. Cosine inverse was restricted to 1 and 2. So whatever answer you got for cosine inverse, it had to be between 0 and pi. Or if you're looking at the unit circle, it had to be the top half. Now all of these are basically following the same idea. If I were trying to simplify a sine inverse problem, well, how will I know what quadrant to draw my triangle in? 1 or 4? There you go, the ratio. Look to see if it's positive or negative. Positive is quadrant 1, negative is quadrant 4. Same thing for cosine inverse. The sine of x, your ratio, if it's positive, it's quadrant 1. Negative would be quadrant 2. Okay, now, does anybody remember what's the restriction for the ratio on tangent inverse? Oh, no? This one's kind of a trick question. There is no restriction. Okay, so basically, as long as it's a real number, any ratio can go into tangent inverse. Okay, but now there is a restriction on the answer that I get. What two quadrants was tangent inverse going to be restricted to? It's 1 and 4, just like sine inverse. But there was one big difference. It had to go from negative pi over 2 to pi over 2. But what was the difference between tangent inverse and sine inverse? It has to do with the boundaries.
Oh, they're open.
There you go. You'll notice over here is sine inverse including the negative and positive pi over 2. Yes, but tangent inverse cannot. Okay, because tangent is undefined at pi over 2 and negative pi over 2. Okay, and let's just see what happens. Give me some value between negative 1 and 1. 0.5, let's say 1/2. Okay, so if I come on over here to my calculator, okay, let me go ahead and get rid of that. Let's see, document B. I'm going to have to use my mouse. Okay, so let's go ahead and plug in sine inverse. Now, where do I find my trig functions? Just trig right here, okay. So if I hit trig, interesting, it's not letting me do that. Okay, give me 1 second. Okay, so let's go to A. Whoops, didn't mean to do that. Okay, so trig, here we go. Here's all my 6 trig functions and the inverses. So let's say sine inverse, Brandon said 0.5, which is definitely between negative 1 and 1, right? So if I push enter, it's going to give me an answer. Now, is that degrees or radians? Degrees, because that's the mode that my calculator is. Okay, so I know that with a ratio of 1/2, I'm going to have an angle of 30 degrees, right? If I try to go ahead and plug in a ratio outside that interval, give me something bigger than 1 or smaller than negative 1. 35. So if I try to take sine inverse of 35, you know, something that is well outside this interval right here, what should happen? Yeah. See, it tells me there's a problem. I'm not going to be able to find an answer for that. Okay. Now remember, you don't have to have these memorized. It's probably not a bad idea if you're comfortable with them, but like on the quiz Thursday, what are you going to be allowed to do? Yeah, you're going to be allowed to use your notes. Okay. So you're probably thinking, wow, I missed all of this during the 2 weeks. Okay, it's one of those things you don't know what you have until it's gone. Absolutely. Okay. Well, let's go ahead. Let's do some problems now. Okay. Let's see here. I think. There we go. Okay. So here's the paper that you picked up on the way in today. We're going to work this together. We'll go ahead and work a few problems on our own to get you guys some practice because, you know, said the quiz is on Thursday, and definitely with the test coming up, you know that this material will be on there. But let's go ahead and choose a few of these, work through them, and see what we think. Okay? Yes. Oh, okay. Here we go. Does anybody else need the paper? All right. Well, let's start with number 1. Sine inverse of negative 1. Okay. Now remember, some of these are going to be unique, and you'll see what I mean in just a moment. But let me go ahead and set up a coordinate system here. Okay, so let me go ahead and draw this, and I'll just keep using this for all the problems today, or at least the ones on this slide. So sine inverse of negative 1. Remember, sine inverse is restricted to what 2 quadrants? It's 1 and 4. Okay, so quadrants 1. Whoops. Interesting. Let me see if I can move this back. There we go. So it's going to be either in quadrant 1 or quadrant 4. Now, like I said, this one's unique. Which one might you lean towards to tell me an answer? Why 4? There you go. It's negative, so we'd automatically think quadrant 4, right? So I'm going to go ahead, just draw a terminal side here. Remember, we've been drawing triangles in these quadrants. Okay. So this angle potentially is what I'm looking for, right? Now, what is -1 as a fraction? Yeah, it's just -1 over 1, right? So I'm going to put -1 over 1. Now remember, we said at the very beginning, sine is the opposite over the what? The hypotenuse. Now opposite over adjacent is actually tangent. Okay? So opposite this angle is the -1. The radius is always going to be positive. Now you remember how we did this before the break? How do I find that missing side? Yeah, Pythagorean theorem. Because remember, we were trying to identify what type of special right triangle it is. Is it a 45-45, 90, or is it a 30-60, 90? Well, let's see here. What would the Pythagorean theorem be with x1 and -1? Square root of 3? Well, let's see. The two legs are x and -1, right? So that would be x squared plus -1 squared equals 1 squared. So x squared plus 1 is equal to 1. Because you square a -1, it becomes a +1. But how would I solve this for x squared? There you go. He says 0 because you have to subtract the 1, right? Well, here's the problem. If I go ahead and take the square root of 0 is 0. So I'm told that the length of that side of the triangle is 0. Say that word again. There you go. If when you're drawing your triangle, if the side you're trying to find is 0, you know it has to be a quadrantal. Okay? So let's think about the unit circle. Now remember, sine inverse is going to be restricted to the right side, which is going to have 3 quadrantals with it. Okay? It's going to be at 0, it's going to be at 90, and it's going to be at -90, right? Well, what's the ordered pair at 0? If we're thinking about the unit circle, like the actual coordinate. Oh, neither of those are close. 1, 0. Remember, why do we call it the unit circle? Because the radius is what? It's 1, right? Okay. So this ordered pair would be 1, 0. If this right here is the origin. What's the coordinate at 90?
0.
That's 0, 1. And then down here, what would -90 be? 0, -1. So if it's a quadrantal, well, all you have to do is look for what the trig function wants. Sine, what was that? Was that x or y? That's y. So look at these 3. Which of these has a y value that's -1?
None of them.
Oh, none of them?
Wait. Oh, the last one. Oh, so it's x, y, right?
There you go.
Never mind. My bad.
So what would the sine inverse of -1 be? Oh, well, not 90. -90. -90. Okay. -90 degrees. Now, what would that be as a radian? How do I convert it if I don't remember the value? Times pi over 180. There we go. If you were to do that, you're going to get -pi over 2. Okay. But let's check it. Let's check real fast. Because we can use the calculator. Okay. I'm using the diagrams and the protractors more just to help you make that connection. So let's plug in sine inverse of -1. So I'm going to come on over here, sine inverse of -1. Now, because mine's in degrees, what should it give me? Well, we got 2 answers. Was it -90 or -pi over 2? Should be -90. There we go. Now, if it were in radians, then it would give me the decimal value for -pi over 2, whatever that is. Okay. All right. Let's try another one. Okay. Like I said, we're doing this together. It's been a while. I just want to make sure that you feel okay with it. And if you have questions, please let me know. Okay. We'll kind of start skipping around a little bit. Why don't we go? Let's go to number 6. Cosine inverse of -1/2. Okay. Cosine inverse of -1/2. So this is -90 or pi over 2 negative. There we go. Okay, so cosine inverse, what 2 quadrants was he restricted to? No, sine inverse is 1 and 4, but cosine inverse. We're on number 6. It's 1 and 2, right? Okay, so this has got to be quadrant 1, or it's got to be quadrant 2. Which one? Where would the -1/2 put me? 1 or 2? Why 2? Because it's negative, and that's where x is negative, right? So in my quadrant 2 here, I'm just going to draw a terminal side. Always connected to the x-axis. There's my triangle. Okay. And this one's already a fraction. -1 over 2. What was cosine's ratio? Sine was opposite over hypotenuse. So x over r. There you go. So we're talking adjacent over the hypotenuse, right? Okay. So the adjacent would be the 1. The hypotenuse would be the 2, right? Which one has to have the negative? The 1 or the 2? The 1. The hypotenuse is always, always, always positive. So it's got to be one of the 2 legs that has the negative. Is everybody okay with how I set that up? Okay. All right. Well, we know it's got to be quadrant 2. We set it up. Well, in order to figure out what type of triangle this is, I need to find that missing y, the height. Well, how do I do that? The Pythagorean theorem. So what 2 sides would I square and add? The -1 and the y, because those are my legs. They form the right angle. 2 is the hypotenuse. So y squared plus -1 squared equals 2 squared. What's a -1 squared? 1. So y squared plus 1 is equal to 4. Then I would have to subtract the 1. So y squared equals what? 3. But I want y. So what would I do to get y from y squared? Square root both sides. So what is y? Square root of 3. Now, is this a quadrantal? Why? The first one turned out to be a quadrantal. There you go. It only becomes a quadrantal if the missing side is 0. So here we know we got a triangle. Now here's the question. Is it a 45-45-90 or a 30-60-90? How do we know? There you go. That's exactly right. It fits the patterns of that 30-60-90. We can immediately throw out 45-45 because, okay, these 2 sides, the legs, are not what? They are not the same. They have to be the same if it's a 45-45-90. Remember, sign does not matter. That negative just tells me the direction we're going. But Brandon is absolutely right. The hypotenuse is double the shorter side. And if I take the shorter side and multiply it by the square root of 3, I would get the square root of 3. So here's my question. This reference angle right here, is that the 30 or is that the 60? So you're saying 30 would go here? And then 60 would go here? Yes. Now here's the thing. My answer isn't 60. What am I forgetting? Remember, where do we always start rotating from? We always start rotating from the positive x-axis. Remember, we call that standard position. So if this right here, if I know half of it is 180, and I rotate to where there's only 60 left, well, how far did I actually rotate? 120. Okay. Now let's check it. Let's see. If I plug in cosine inverse of a -1/2, it should give me 120. So let's see here. Cosine inverse of -1 divided by 2. There's my 120. Okay. There we go. Now, what if I wanted that in radians? Yeah. So you got the 120 there. Just go ahead and say times, parentheses, control divide. I'm going to put pi over the 180. Okay. Now, of course, it's going to give you, the decimal value, but you can probably just simplify that expression. Yes. No, it wouldn't be 3 pi over 4. 2 pi over 3. Mm-hmm. There you go. There you go. Now, it's been a while, but is this starting to come back? Maybe, maybe not. Okay, let's do another one. And with it already being 12:20, we're probably going to go ahead and just do this again tomorrow. I'm in no rush. Okay, no rush at all. Let's go ahead. Let's do a tangent one now. What do you think? Let's do 5. Tangent inverse of negative square root of 3. Okay. So what 2 quadrants is tangent inverse in? 1 and 4, just like sine inverse. Okay. So it's got to be quadrant 1 or it's got to be quadrant 4. Okay. So which one, because it's negative? There you go. If it's negative, quadrant 4. If it's positive, then it would be in quadrant 1. Okay, well, this one's not a fraction like the previous one. Well, how can I write negative square root of 3 as a fraction? There you go. I can always put anything over 1, right? So is everybody okay with how we know it's quadrant 4? Okay, it's negative. So in quadrant 4, I'm going to draw just a terminal angle. Okay, terminal side right there. Well, how do I finish the triangle? I always hook it to what? There you go. Always hook it to the x-axis. Okay, so this is the angle theta I'm looking for. Now, the reason I wrote it as a fraction, now that I've got the triangle, what is tangent's ratio? It's always y over x. It's y over x, or it's opposite over adjacent. Okay, so from theta's perspective, the square root of 3 is opposite that, and the adjacent is the 1. Which one would have the negative? The square root of 3. Because, see, if you were to go from the origin to this point here, the negative would have to tell you to go down, right? Okay. Is everybody okay with how I'm creating the triangle? Well, what do I do now? I got to do the Pythagorean theorem to figure out what type of triangle it is. Okay. So using 1, the negative square root of 3, and r, what's the equation I would need to set up? There you go. These are my legs because those create the right angle. So this would be 1 squared plus negative square root of 3 squared is equal to r squared. Okay, so 1 squared is what? 1, that's easy. Plus, now if I square a negative, it's definitely going to become positive. What happens if I square a square root? Cancels. So what would I have? It would just be 3 is equal to r squared. So 1 plus 3 would be 4 is equal to r squared. So r, the radius, would be 2. Okay, so 2. And here's my question. Is it a special right triangle? Okay, what type? This one's a 30, 60, 90 as well? Why isn't it 45, 45? Okay, the 2 legs would have to be identical, so that's off the table. Which one would this one be here? Would this be the 30 or the 60? There you go. Remember, the 30 is always across from the shortest side. And 1 is smaller than the square root of 3, right? But now, here's one thing we may not remember. Is my answer just 60 degrees? What am I forgetting? Oh, no. Now, remember, we always rotate from standard position, but to get into quadrant 4, we have to rotate clockwise, which means my answer is negative. If you're simplifying a sine inverse or a tangent inverse problem, and it's in quadrant 4, guaranteed your answer will be negative. Okay. In fact, let's check it. Tangent inverse of a negative square root of 3. So I'm going to come back over here. Let's see. So tangent inverse of a negative. Oh, that did minus. Sorry about that. Let's do negative square root of 3. So if we are right, it should give me a negative 60. There you go. Just like that. Is this coming back to you? Okay. Now, it doesn't look like we're going to go ahead and get to any today, but where is the protractor coming from? Why do we even need a protractor? There we go. What if one of the triangles is what? Like ambiguous. What do you mean? Well, what kind of triangles are we looking for? Special right triangles. So is it possible to get a triangle that's not special? Yes, that's when the protractor comes in and we'd have to measure that. Okay, but I'll tell you what, let's go ahead and do one more of these. And then tomorrow when we come in, we'll go ahead and look at the protractor. We'll focus on that aspect of it. That sound good? Okay. All right, let's see. We did numbers, we did 1, 5, 6. Let's do a 4. Let's do 4, and then I'll be good for this first section. Sine inverse of the square root of 2 over 2. Okay. Now, sine inverse, what two quadrants am I restricted to? What side? It was 1 and 4. 1 and 2 was cosine inverse, right? So I'm restricted to 1 and 4. Which one is it?
1.
Why 1? Why can't it be 4? It's positive. Always look at the sign of your ratio to tell what quadrant. Okay, so it has to be quadrant 1. I'm going to draw my terminal side. Always connect it to the x-axis. Okay, just like this. So this is what I'm looking for, that angle theta. Okay. Well, what have we been doing in the past? How do I know 2 of the 3 side lengths already? Uh-huh. Okay, he says because it's already a fraction and because we know sine is y over r. Okay, so we know that the opposite y, this would be the square root of 2. Let me go ahead and move this off so it doesn't run together. And then the radius is 2. So what side length am I actually missing? X, right? Okay. The adjacent. So how do I find that missing side? Okay. So what 2 sides, is it x2 or the square root of 2, will I square and then add? What are my a and b? Okay, he's right. It's the x and the square root of 2. It's always the 2 sides that form the right angle. So let me take this out here. So x squared plus the square root of 2 squared. So that means it should equal 2 squared. Always the hypotenuse squared. Okay. Well, what happens when I square a square root again? Cancels. So this would be x squared plus 2 equals 2 squared? 4. Now what? Okay, subtract this 2. Those cancel, so x squared equals 2. And how do I get x from x squared? There you go. So this missing side length is the square root of 2. Okay, and here's my question. Is it a special right triangle? Yes. Now which one? Is it another 30, 60, 90? Well, they've all been 30, 60, 90s today. How do you know it's a 45, 45 number? There you go. Okay. These 2 sides, the legs, are exactly the same. And also, if you take one of the legs and multiply it by square root of 2, it will give you 2. So see, it fits the pattern. So this is a 45. This is a 45. So the sine inverse of the square root of 2 over 2 is just 45 degrees. And what do you think we're going to get if I plug that in the calculator? Will it give me the 45?
Yes.
Absolutely. And what's equivalent to 45 degrees? Pi over, not 3, 4. Pi over 4. There we go. Either of those just depends on what measurement you want to take it in, degrees or radians. Okay. How we doing? Are we remembering it? Okay. All right, so I'll tell you what, I'm not in any hurry. Tomorrow when you come in, we'll go ahead and look at this next section, and we'll go ahead and start looking at the ruler and the protractor. Okay, so if you want to hang on to that, just bring it back with you tomorrow, or if you want to go ahead and put it in the tray, that way you know it's safe until you come back tomorrow. I won't touch it. Whatever you want to go ahead and do. All right, good, 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 good.